and welcome to Algebra 2 tutorial. In this video, we are starting our new subject, trigonometry. And so, if you don't know what trigonometry is, you'll be able to fit right in with this, but if you do know what trigonometry is, this will still be a good introduction. Trigonometry is all about right triangles. And then we do extend it beyond right triangles eventually, but it starts with the geometric shape, the right triangle. So if we've forgotten everything, we're going to start with what is a trig ratio. And then from there, we're going to take a look at all 6 trig ratios that we have. In geometry, you usually take a look at the first 3, sine, cosine, and tangent, but there's 3 more to add after that. And then we can use these trig ratios to solve for the sides of triangles. So first, let's go back to the basics. What is a trig ratio? So trigonometry starts with right triangles, and we look at the ratios of their sides. So the ratio is just a fancy word for fraction. And so the 3 that you probably remember are sine, cosine, and tangent. So sine, we usually abbreviate it like this when we write it mathematically. And in the inside of sine, that function, we put an angle. And we usually use the Greek letter theta for angles. For some reason, we use Greek letters for angles. And we define sine as the opposite side over the hypotenuse side of our right triangle. Cosine is just cos. That is the adjacent side over the hypotenuse. And tangent, we abbreviate TAN, is the opposite over the adjacent. And hopefully you've seen the mnemonic device SOHCAHTOA to help you remember that. So S stands for sine, O for opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent is the opposite over the adjacent. It sort of helps you remember that. But so these ratios, these fractions are set for certain angles. And I want to show you how that works, where these numbers for sine, cosine, and tangent actually come from. So here is our right triangle. And I've set up this right triangle to have a 55-degree angle or something pretty darn close to it. And no matter where I move this triangle, that 55-degree angle stays, and so does the 90-degree angle to make sure we have a right triangle. So what we're going to do is take a look at the ratio of sides. So I'm just going to pick sine. And so we're going to be looking at the sine of 55 degrees. So that is the opposite over the adjacent. So if this is our angle right here, the opposite is over here. So I said adjacent, and I meant hypotenuse. And our hypotenuse is the longest side over here. So if you take the opposite side, 4.81, divided by the hypotenuse, 5.86. And so if we do that division there, 4.81 divided by 5.86, we get 0.82 approximately. 0.82. So now I'm going to do it again, but I'm going to do a different triangle, but it's still going to be 55 degrees for that angle. So here I'm going to change this triangle, get much, much bigger. But you can see we still have the 55-degree angle. We're still a 90-degree right triangle, but all the sides are different. And here's where the power of trig really comes in. So this is still the opposite side, and this is still the adjacent side. And so if we do this again, now it's 9.47 divided by 11.55. you can see the numbers are completely different. It's a different triangle with just this one similarity, the 55 degrees. So we're going to do that division again. So this is now 9.47 divided by 11.55. And you can see we get pretty much the exact same number. It's got a little round off error because the GeoGebra file isn't perfectly accurate. But you can see that is 0.8, and that 1 definitely rounds up with 2 nines to a 2. And so we again get 0.82 for our ratio. Now that is the power of trig, that I completely changed the triangle. The numbers are completely different, but because that 55-degree angle stays, the ratio, or the fraction of opposite over hypotenuse, is the actual same ratio. And that works for all right triangles, no matter which way I do this, how big or how small I make it. If I take the opposite divided by the adjacent, it will always be 0.82 as long as you have that 55 degrees. And so that ratio we store on the calculator. If I just do sine of 55, we have this 0.82 stored in the calculator. So you can see a little bit of round off error, but that's essentially the 9 rounds the 1 up to 2. And so we get that number stored in the calculator. So sine of 55 is always 0.82, no matter what triangle you have, if that angle is 55. So let's take a few summary statements from that. So here are some trig values that I looked up here. The sine of 68 is 0.927. What does that mean? All right, so that means that every right triangle with a 68-degree angle will have, now I'm going to say something about the ratio. Now what ratio do I know something about? Sine is opposite over hypotenuse. So we'll have an opposite over hypotenuse ratio of 0.927. So no matter how big or how small this triangle happens to be, if I take the opposite and divide by the hypotenuse, it will always give me 0.927. So now this one, what does this statement mean? Tangent of 35 is equal to 0.7. That means that every right triangle with a 35-degree angle will have, now what ratio do I know? Tangent is opposite over adjacent, so we'll have an opposite over adjacent ratio of 0.7. So every time you see a trig statement like this, there is a right triangle happening in the background. You may not draw it all the time, but it is there. All right, so that's a quick introduction to what trig actually is. Let's use this information next. And by that, I mean, we're going to extend it now to 6 new trig ratios that you maybe haven't seen. Okay, so sine, cosine, and tangent are the original 3. So here we got them. We know what these are. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now there's actually 3 more. They're the reciprocal trig functions. So each of these has a pair. Sine has one. It is called cosecant. Cosine has one. It is called secant. Tangent has one. It is called cotangent. That's sort of the easy one to remember here. And so they are the reciprocals of their pair. And so we abbreviate cosecant as CSC, and it's the reciprocal, hypotenuse over opposite. Secant, we abbreviate SEC, and so that's the reciprocal, hypotenuse over adjacent. And cotangent, we abbreviate COT, and that is adjacent over opposite. Oh, I made a mistake that actually makes me angry. There we go. It should be cotangent of an angle. You always have to have the angle here. You can't just stop writing that. There we go. So we have these three new trig ratios. That gives us a total of 6. But the other 3 are just the reciprocals. So the main thing you have to do is get the names correct. Cotangent is easy, but these two you have to just remember those, that sine becomes cosecant, cosine becomes secant for the reciprocal. All right, so let's use that a little bit. So here we have a problem. A right triangle satisfies cosine of 56 is equal to 5 over 9. Find the ratios of the other 5 trig functions. So I'm going to draw this triangle. It needs to be a right triangle. Now I can put this 56-degree angle anywhere I want. It can either be here or here, as long as I put the 5 and the 9 in the correct place. So I'm going to switch it up. I'm going to put the 56 here. So cosine is adjacent over hypotenuse. Well, the hypotenuse is easy. It's the longest side. So that one has to be the 9. The 5 is the adjacent. So if this is my 56, where is the adjacent side? It's the side right next to it. So this is the 5. And this is the opposite, but we don't know what the opposite is right now. So our first one that we have is cosine of 56 is equal to 5 over 9. So we need sine, tangent, and then the 3 reciprocals after that. Well, we have the one reciprocal. Secant is actually really easy. Secant of 56 will be 9 over 5. It's simply the reciprocal of cosine. So we get that one for free. But now we need the others, and to do that, we need the opposite side. What is this number? Well, we can use Pythagorean theorem real quick to get that. 5 squared plus b squared is equal to 9 squared. So we have enough information. That's 25 plus b squared is equal to 81. Subtract the 25 from both sides. So that is 60, 56, it looks like. And then we need to square root both sides so that b is equal to, that one I can't do in my head, oops. So we need the square root of 56. Gives us, let's call that 7.5 just for easy calculations. 7.5. All right, so if this down here is 7.5, we can now do all our other trig ratios. So sine of 56 is equal to the opposite, 7.5, over the hypotenuse, which is 9, and tangent of 56 will be equal to the opposite, which is 7.5, over the adjacent, which is 5. And then our reciprocals, cosecant will just be the reciprocal of this, and cotangent will be the reciprocal of this. So we identified all 6 trig ratios just by knowing one of them. That's pretty powerful. All right, so a little practice there for all 6 trig functions. Now we're going to use these trig functions to solve for the sides of a triangle. So here we have a triangle, but we don't know all the information. We know an angle and we know a number. Can we find the other 2? So what I need to do is set up a trig function that uses 25 degrees and the 9, the hypotenuse. And so I can pick either one of these. Let's label them. Here's my 25. This one is going to be the opposite, and this one is our adjacent. So let's pick one. Let's pick sine. That's the easiest one usually. So sine of the angle, which is 25, is equal to the opposite, which we don't know, so I'm going to call that x, over the hypotenuse, which is 9. I'm sort of rounding to make the numbers a little bit nicer. Hopefully you get the concept here. Well, sine of 25, that is the same for all right triangles, and that is in our calculator. And so all we have to do is go to our calculator and type in sine of 25. And it tells us sine of 25 is 0.42. And now we have a rational equation, which we could cross multiply, I suppose, but because we only have one fraction, we can probably just multiply by 9 on both sides, so that x is equal to 9 times 0.42. 9 times 0.42 is 3.78. So this one is 3.78. Now it's time to do the adjacent. So I need a trig function that uses adjacent, and that would be cosine of 25 is equal to the adjacent, which let's call that one y, I suppose, just another letter, over the hypotenuse, which is 9. And this is going to be the exact same thing. I'm going to do this on the calculator, which is not 0.42, it's different, it's cosine. And then we're going to multiply by 9 on both sides. So I'm going to sort of do that in one step. Cosine of 25. And then we're going to multiply by 9 on both sides to get y. It's let's call that 8.2 to have it round up. So that y is equal to 8.2. There we go. So that's how we can use these trig functions to solve for missing sides when we only know one of them. I think that's a pretty good introduction to trigonometry. Remember, trigonometry is all about right triangles and the ratio of the sides. We now have 6 of them: sine, cosine, tangent, and then cosecant, secant, and cotangent, the reciprocals. So here's a few practice problems. See if you can use those 6 trig functions. Good luck.